So folks, in this video I'm going to do a review of partial fraction decomposition, which is a tool that you hopefully learned in Calculus 2 or at least some other math class. And if you haven't learned it or if you've forgotten it, well, that's why we're doing this. What's the goal of partial fraction decomposition? Well, one way to look at it is if I were to take the fraction 11/15, I could rewrite the denominator in terms of its prime factors. The number 15 could be written as 3 times 5. And then taking just this piece of it here, I might ask the question, if I wanted to break this up into two fractions, a sum of fractions, over those multiples of the denominator, we would say, well, what A plus what B would make this true? Okay? And that's what we're going to do in this technique of partial fraction decomposition. So we're going to try to find A and B so that when we add the two fractions together, we end up with this fraction of 11/15. So we're going to do this, though, with polynomials. And the first thing I need to say is it's important that this polynomial be written in lowest terms, and I'll highlight that in another example. But this one is. It's already been reduced. So we want to decompose this polynomial, and that is, if I first rewrite it in terms of its prime factors, well, this is the factor x minus 3 times the factor x plus 2. And if I wanted to break this up into a sum, I could write it as something over x minus 3 plus something over x plus 2. And that's the process of decomposition, but the task that remains, and not always the hard part, is to find the a and the b. So the trick that we're going to do is we're going to take this expression, and on each side of it, I'm going to multiply it by the least common denominator. So let me do that. So when I do that, I'm just left with x minus, or excuse me, on the left-hand side, I'm just left with 3. And on the right-hand side, after I clean things up, I've got a times x plus 2 and b times x minus 3. So now what we're going to do is we're going to eventually make a positioning argument. And actually, this same positioning argument shows up in differential equations many different times. So it's a good one to review anyway. So I'm going to go ahead and distribute. Now what I'm going to do is I'm going to go ahead and collect together the terms by their powers of x on both the left and right hand side. So first of all, I'm going to rewrite the left hand side as 0x plus 3, and on the right hand side I'm going to collect the x terms and then the non-x terms. This gives me, so from here I'm going to make that positioning argument that I mentioned. I'm going to equate the coefficient of x over here with the coefficient of x on this side. Likewise, I'm going to equate the coefficient of the linear term with the coefficient, or the constant term with the coefficient of the constant term on the other side. This gives me two equations. The first being that 0 needs to be equal to a plus b. That's the first equation. And the second equation is that 2a minus 3b needs to equal 3, which I got from what I've underlined in blue. So what do I need to do now? I just need to solve this system of equations simultaneously. The first one is straightforward. We get that a is equal to negative b, and if I plug that result into 2, this gives me that 2 times negative b minus 3b needs to equal 3, or minus 5b needs to equal 3, or b needs to equal negative 3/5. Since a is the opposite, we get that a is equal to a positive 3/5. So at long last, and I guess I haven't given myself enough room here, at long last we can take this original fraction, which was 3 over x minus 3 times x plus 2, and say that that is equal to 3/5 over what was a, that goes over the factor x minus 3, plus negative 3/5 all over the factor x plus 2. And there we've decomposed this fraction. We're going to do some variation of this technique over and over again, but there's a few other things we need to see first. The last thing I want to say is that if you're curious, there are some nice shortcuts to this procedure. So you could take a look in our textbook, or you could Google shortcuts to partial fraction decomposition. However, those shortcuts don't really help with all of the other forms. They would help in this case, and so it's important to originally learn the procedure before you learn the shortcut. That's all I've got for this video. We'll pick up in number 3 here.